For our third example, we have iron metal reacting with chlorine gas to make Fe, or to make iron chloride. And how many moles of the iron 3 chloride can be made from 15 liters of chlorine? So we need a balanced chemical equation. The iron chloride is a metal plus a nonmetal, so it's ionic. We have to deal with charges. That Roman numeral 3 tells us that iron is 3 plus. Chloride is going to be 1 minus. So we're going to have Fe, and let's see, Fe with a 3 plus, Cl with a 1 minus. When we crisscross, we're going to end up with FeCl3. Oh, whoops, that's what we're going to make. Let me just erase that and move that over a little bit. Didn't leave myself enough room there. All right, so yeah, FeCl3 is a product. And it's made by reacting iron with chlorine gas. In class, often when I first write this, I leave chlorine gas as Cl, and I hope that some student will tell me, wait a minute, isn't that supposed to be Cl2? When chlorine is all by itself, it's diatomic, along with all of the other Brinkelhoffs, bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. If they're solo, if they're all alone, we have to give them a subscript of 2. To balance this, I've got that even-odd problem. I've got 2 chlorines on the left and 3 on the right. So their least common multiple would be 6. So I'm going to shoot for 6 on each side, which means I need a coefficient of 3 in front of chlorine and a coefficient of 2 in front of FeCl3. And that just messed up my irons. I now have 2 on the right and just 1 on the left. So I also need a coefficient of 2 in front of iron. To start the calculation, we've got 15 liters of chlorine. So that's what I want to start off with. 15 liters of Cl2. And then since I don't have moles, I want to convert from liters to moles. So I'm going to take liters of chlorine and turn that into moles of chlorine. Since the chemical remains the same, what's changing is the unit, so that's just a mole triangle conversion. With liters, we've got 22.4, and with moles, we have 1. That's just converting liters to moles using the mole triangle. The next step in the traditional way, now that we have moles of chlorine, we want to use the coefficients to convert from chlorine to what we're looking for, which is the iron 3 chloride. So I'm going to put moles of chlorine on the bottom, and I'm going to put iron 3 chloride on the top, and that's got to be moles. The numbers that we're going to put here are the coefficients from the balanced equation. Iron 3 chloride has a coefficient of 2. Chlorine has a coefficient of 3. And then last but not least, oh, wait a minute. We get lucky in this problem. We are asked to find moles of iron 3 chloride. So we're actually done. When we get to this third step, we are done because we are looking for moles. And that's where we are. We have found moles of iron 3 chloride. So my units are going to cancel out. I'm going to have liters of chlorine canceling and moles of chlorine are canceling, leaving me moles of FeCl3. And running that through my calculator, I'm going to get 0.45 moles of FeCl3. I'm rounding to 2 sig figs, assuming that the 15 is 2 sig figs. I know it's a nice whole number, but it is liters, which is something you have to measure. So I'm going to assume since they wrote it that way, it's got 2 significant figures, since measurements are the numbers that sig figs matter for. For the alternate approach to this problem, unfortunately, the alternate approach doesn't get any shorter because it's moles, the way that the traditional approach got shorter for moles, but that's okay. It's still a shorter approach. We had 15 liters of chlorine, and I just realized I didn't write the balanced equation. I really should start with the balanced equation because we're going to need it. The balanced equation was 2 irons react with 3 chlorines to make 2 iron 3 chlorides. Okay, so there's our balanced chemical equation. We're going to build these conversion factors by starting with the unit and the chemical that we're given. We're given liters of chlorine. We are looking for moles of iron 3 chloride. So moles of iron 3 chloride are going to go on the top. We need to put 2 numbers here because we have to convert both the unit and the chemical. So with liters, we use the number 22.4, and the coefficient on chlorine is 3. On the top, we've got moles of FeCl3. So the number that goes with moles is 1, and the coefficient on FeCl3 was a 2. When I run these numbers through my calculator, I'm going to end up with 0.45 in terms of units. Liters cancel out, liters of chlorine cancel out, leaving us units of moles of FeCl3. For our fourth example, this is one that involves chemicals that we have not learned the nomenclature for. So I'm just giving the balanced chemical equation here. We have toluene, and it reacts with nitric acid to make something called trinitrotoluene, which is abbreviated TNT. We also get 3 moles of water as a byproduct in this chemical reaction. To save a little bit of time, I'm just going to go ahead and give you the molar masses. The molar mass of toluene is 92.14 grams. And the molar mass of TNT is going to be 227.13 grams. All right. In our traditional approach, we're going to take the given number, unit, and chemical, 829 grams of toluene. The bottom of my next step has to match the units in the chemical. So the bottom of my next step is grams of toluene. The first step in the traditional approach is to take whatever units we were given and convert those to moles. So I want to put moles of toluene in the top. Since it's toluene in the top and the bottom, this is a mole triangle conversion. The number in the mole triangle with moles is 1. The number that goes with grams is the molar mass, so that's going to be 92.14. The next step, since we now have moles of toluene, is to use the coefficients to convert to moles of the other chemical. So we've got moles of toluene, and we want to convert to moles of TNT. And the coefficients in the balanced equation are both 1s. And last but not least, we want to convert to the unit that was requested. We were asked to find grams. So we're going to put moles of TNT down in the bottom and grams of TNT up in the top. This is a mole triangle conversion. 1 mole has a mass of 227.13 grams. Again, I pre-calculated the molar mass up top here. That's where that 227.13 grams comes from. That's just the molar mass of TNT. When I run those numbers through my calculator, I'm going to get 2043.529 and a bunch of other digits. The given, the 829, only has 3 sig figs, so I'm going to round that to 3. 1, 2, 3, which means I'm rounding to the tens place. This would round to 2040. And in terms of units, grams of toluene have canceled, moles of toluene have canceled, moles of TNT canceled. That's going to leave grams of TNT. To do this the traditional way, we need some of that stuff from the previous slide. The molar mass of toluene was 92.14 grams. The molar mass of TNT was 227.13 grams. What we were given was 829 grams of toluene. So we start with the number, the unit, and the chemical that we're given. Down in the bottom of the next step, I'm going to write the unit and the chemical of the given. In the top of the next step, I'm going to write the unit and the chemical that we're looking for. We were looking for grams of TNT. On the mole triangle, the number that's associated with grams is the molar mass. So for TNT, the molar mass was 227.13. For toluene, the molar mass was 92.14. And the coefficient from the balanced equation also has to be here. And for both chemicals, both TNT and toluene, the coefficient is a 1. And if I run all of that through my calculator, once again, rounded to 3 sig figs, I'm going to get 2040 grams. And it's going to be grams of TNT because the grams of toluene have canceled out. Getting close.